In this video, we are going to take a look at interval notation. And in the last video for set builder notation, we talked about natural numbers, which is our set n, 1, 2, 3, 4, so on and so forth. Our integers, set z, and our rational numbers like a half, 0.25, 0.351 repeating, and then any repeating number, and we call that the set q. Let's try that again. And then we have the real numbers, and these are our rational and irrational numbers. And for interval notation, we're going to be talking about the set of real numbers. Let's look at a few examples here. First of all, we're going to talk about bounded intervals. These are intervals with boundaries on both ends, that is. And so we'll start with a graph for each of these. We want to describe all the real numbers that are greater than -5 and less than 10. As a graph, we have our two boundaries at -5 and 10. Now notice here we're talking about all real numbers, because again, interval notation is only for real numbers. And at these two, since it's not or equals to, at these two boundaries, we're going to have round brackets, or what we call soft brackets. Okay, and we will have all the numbers in between are the numbers that we are describing here. And so that's how we graph it. Once again, we have these soft brackets. It's kind of like an open circle that you might use or have used in the past. As interval notation, we would write -5 and 10. Now this again is a bounded interval because we have two boundaries, this one on the right and this one on the left. One more way to describe it is this is an open interval. It's open because there is no, the boundary is not included. Okay, there's no hard boundary. If you pick a number that's close, like 9.999, well, there's a closer number than that, 9.999999. And you can always get numbers that are closer and closer and closer to the boundary, but you'll never touch the boundary because it's not included. So that's the type of interval, and this is the interval notation here. Then we have all numbers, and we looked at this in the previous video on set notation. And so here we want numbers that are non-positive. What makes this non-positive? So this could be negative or it could be 0. Well, the numbers that make it 0 are -4 and 4. Test it out and plug those numbers into x, and you'll see you get 0. So these numbers are included. So since they're included, we're going to use hard brackets, or these square parentheses, kind of like a solid dot. And then we're going to include all the numbers in between, because if you plug in 0, you're going to get you plug in 0 here, you're going to get 0 squared minus 16, which is -16. That is a non-positive number. You plug in 1 squared minus 16, you're going to get -15. So the number 1 right about here is included, gives us -15. So to write this as an interval, we get -4, 4. And that is your interval notation. Now this is what we call a closed interval. It's closed because of the hard brackets on both sides. We are including both of the endpoints. Alright, so that's a closed interval. Finally, we want to look at unbounded intervals. And so our first example, we want to describe all real numbers greater than -5. Quick picture helps us see what's going on. Down here on our number line we have -5 somewhere. And since it's not or equals to, it's just greater than, we're going to have a soft bracket. Arrows going to the right. This is going to go all the way up to a million, trillion, all the way up towards infinity. But it's never going to reach infinity because infinity is not a number. And so we have the interval -5, and we go up to infinity. We never reach it, so we have a soft bracket there. And so this is the interval notation. And you can see why we have changed from circles to parentheses here, our brackets, because it relates nicely to our interval notation. And this is an open interval because it has two soft brackets. Next we want to describe all real numbers that are less than or equal to now. So we have less than or equal to -5. So our picture looks like this. Let's slide -5 over here. And it's or equal to, so we're going to put a hard bracket here at -5. And we're going to draw an arrow to the right. Nice sloppy arrow here. And so this goes down to negative infinity. So down here is what we call negative infinity. All the way down, we've got negative a million, negative billion. Keeps getting smaller and smaller, smaller. So we have -5 is our boundary on the right, and negative infinity is our boundary to the left. But we never reach infinity because it's not really a number. And so there is our answer in interval notation. Now this is what we call a half open. It's half open because we have one hard bracket and one soft bracket. Now we could also call it half closed. Is the glass half empty or half full? You decide. Either way is fine. Finally, we have all positive numbers. We want to describe all the real numbers that make this expression positive. And in this case, we have one more little twist here. Well, we know that when x is 4, we get 0. So when x is 4, we get 0. When x is -4, we get 0. What numbers make this positive? Well, this has to be larger than 4. 4 is not included here. So we're going to put a soft bracket at 4, and all the ones that are bigger, going up to infinity, will give us a positive number. But because of the squaring here, because of the x squared, if we put a -4 or -5 in here, -5 would give us 25 minus 9 is 16. So that would be fine also. Sorry about that. 25 minus 9 would be, minus 16 would be 9. And so we have all these numbers down here. Now, we have two groups. The one on the right over here is from 4 to infinity. Those numbers work. The one on the left is from -4 down to negative infinity. And we want to glue those together, and we do that with this symbol, which is called the union. And so this is our solution. This is describing two intervals, and they're put together by a union. They're both open, so this would be a fully open interval. It's an open, unbounded interval. And there you have it. So we've now seen that interval notation can be bounded or unbounded, and the intervals can be open or half open or closed. And that is pretty much all that we need for interval notation.